Mars isn't a second Earth. It's a desert that has been killing things for over 3 billion years. And by the end of this video, you'll understand why the dream of moving humanity there may be the most dangerous mistake we could ever make. Let's start with what Mars actually is, because the popular image of it has been carefully sanded down by science fiction. Mars is small. It's just over half the diameter of Earth, with about 38% of our gravity. That alone sounds harmless, even charming. You'd weigh less. You could jump higher. But gravity isn't a number on a chart. It's the invisible architecture of the human body. Our bones, our muscles, our blood, our eyesight, every system inside us was built over millions of years to push back against a single, specific pull. Take that pull away, and the body starts forgetting how to be a body. Astronauts on the International Space Station, who train obsessively and exercise nearly 2 hours every single day, still lose roughly 1% of their weight-bearing bone density every month they spend in microgravity. Their muscles atrophy. Their hearts shrink. Their blood volume drops by up to 22%. Their eyesight changes in ways doctors are still trying to fully understand. And here is the part that should disturb anyone planning a Martian future. A 2024 study published in Science Advances found that 0.67 g, roughly 2/3 of Earth's gravity, is a threshold below which muscle atrophy begins to take hold in mammals. Mars sits at 38 centimos, far below the line, which means a human body on Mars may never stop deteriorating, no matter how many hours you spend on a treadmill. Children born there would grow up under conditions their genome has never been tested against. Their hearts, their spines, their immune systems, all of it improvised by evolution for a planet they would never set foot on. But gravity is the gentlest thing Mars will do to you. Now look up at the sky. On Earth, that sky is a shield. Our atmosphere is dense, layered, alive with weather. It absorbs ultraviolet light, scatters cosmic radiation, and works alongside our planet's powerful magnetic field to keep deadly particles out of our skin. Mars has neither. About 4.2 billion years ago, scientists believe Mars' core cooled and its global magnetic dynamo died. Without that magnetic shield, the solar wind began stripping the Martian atmosphere away, particle by particle, for hundreds of millions of years. What's left today is a whisper. The atmospheric pressure on Mars averages around 610 pascals, less than 1% of Earth's at sea level. That number isn't just small, it's lethal. There's a concept in physics called the Armstrong limit. It's the altitude at which atmospheric pressure becomes so low that water boils at human body temperature. Mars sits well below that limit everywhere on its surface. If you stepped outside without a pressurized suit, the saliva on your tongue, the moisture in your eyes, the water in your lungs would all begin to boil. You wouldn't explode like in the movies, but the gases dissolve in your bloodstream would start forming bubbles. You'd lose consciousness in seconds. And even if you somehow had air to breathe, the atmosphere itself is over 95% carbon dioxide, with barely a trace of oxygen. There is no Martian air to breathe. Not now. Not for as long as the planet has existed. And then there's the cold. The average surface temperature on Mars is around -63 degrees Celsius. But that average hides something far more brutal. Near the equator on a summer afternoon, the surface might briefly climb above freezing. By nightfall, that same patch of ground can plunge to -100. At the poles in winter, temperatures collapse to around -125 degrees Celsius. That is cold enough for the carbon dioxide in the atmosphere itself to freeze out of the air and fall as dry ice snow onto the surface. Roughly a quarter of the Martian atmosphere literally vanishes onto the ground every winter and sublimates back into gas every spring. There's no planet on Earth where the air itself disappears with the seasons. On Mars, it's just Tuesday. Now, let's talk about the radiation, because this is the part that quietly ends most serious conversations about colonization. Earth's magnetic field deflects the vast majority of charged particles trying to reach us. Mars has nothing. No global magnetic field. No thick atmosphere. The surface is constantly bathed in two kinds of radiation. Galactic cosmic rays, which are heavy, high-energy particles flung across the universe by distant supernovae, and solar particle events, which are sudden bursts of energetic protons fired from the sun. On Earth, we're protected from both. On Mars, you stand in the open and absorb them. NASA's Curiosity rover measured the radiation environment in detail. The Martian surface delivers a daily radiation dose roughly 2 to 3 times higher than what astronauts experience on the International Space Station. The European Space Agency has stated bluntly that on a full mission to Mars, an astronaut could receive up to 700 times more radiation than they would on Earth. A 6-month journey alone, just getting there, could expose a crew to at least 60% of their entire recommended career radiation limit. The agency's own physicist, Marco Durrani, has gone on record saying that, as of today, we cannot send humans to Mars within acceptable radiation safety standards. It would be impossible to meet acceptable dose limits. And the consequences aren't theoretical. Long-term radiation exposure damages DNA. It increases cancer risk. It harms the central nervous system. It accelerates cardiovascular disease. It causes early-onset cataracts. Studies on rodent models have shown reduced dendritic complexity and spine density in brain neurons after simulated cosmic ray exposure, meaning the rays don't just risk killing you slowly, they may quietly rewire how you think. To shield a human habitat properly, scientists estimate you'd need to bury it under 1 to 2 meters of Martian regolith. That's right, to survive on the surface of Mars. The most realistic plan we have is to live underground in caves of dirt. The brochure-friendly image of glittering domes under a Martian sunset isn't engineering. It's marketing. But let's say you build your buried bunker. You bring your radiation shielding. You exercise enough to slow the bone loss. You're still not safe because the dirt itself is trying to kill you. Martian soil isn't just lifeless. It's actively toxic. In 2008, NASA's Phoenix lander made a discovery that fundamentally changed how scientists view the Martian surface. The soil contains perchlorates, chemical compounds made of chlorine and oxygen, at concentrations of roughly 0.5 to 1% by weight. That doesn't sound like much. But for context, perchlorate is considered toxic to humans at levels measured in parts per billion. On Mars, it's parts per 100, across the entire planet. Every landing site, every sample, every scoop of regolith. The Mars Odyssey orbiter has confirmed that perchlorates appear to be globally distributed. What does perchlorate do to a human body? It interferes with iodine uptake in the thyroid gland, suppressing the hormones your body needs to regulate metabolism, growth, and brain development. In adults, the damage is reversible. In fetuses, newborns, and children, it isn't. A 2017 study published in Scientific Reports added a darker layer to this. Researchers found that when Martian perchlorates are exposed to ultraviolet radiation, exactly the kind of UV that bathes the unshielded Martian surface, they become bactericidal. Combined with iron oxides and hydrogen peroxide, 2 other compounds present in the soil, they form what the researchers described as a toxic cocktail of oxidants that renders the present-day surface of Mars highly deleterious to cells. In other words, the dirt doesn't just poison you. It sterilizes anything organic that touches it. And it gets worse. Martian dust is incredibly fine, with average particle sizes of about 1 micron, smaller than most household dust on Earth. It's electrostatically charged. It clings to everything. Suits, equipment, airlocks, lungs. NASA scientist Pascal Lee has stated plainly that prolonged exposure to Martian dust would kill an unprotected human over the course of weeks. A 2002 study comparing Martian dust analogs to common silicates found that when these particles react with even small amounts of water, they generate the same kind of reactive molecules that cause lung disease, including cancer, in miners on Earth. It's not just dust. It's a kind of silent industrial accident waiting in every breath. Now imagine where this dust lives. Imagine the storms. Mars has weather, but not the kind we know. Every 5.5 Earth years on average, Mars produces what scientists call a planet-encircling dust event, a storm that wraps the entire globe in opaque, churning haze. In 2018, one such storm doomed NASA's Opportunity rover. It began as a small, local disturbance in late May. Within 2 weeks, it had grown larger than North America and Russia combined. By mid-June, it covered the entire planet. The storm lifted dust to altitudes above 60 kilometers, more than 7 times the cruising altitude of a passenger jet. Sunlight reaching Opportunity's solar panels dropped by nearly 97% in just 8 days. The rover went dark, fell silent, and never spoke again. Only the caldera of Olympus Mons, the tallest volcano in the solar system, peaked above the cloud. Pause on that for a moment. An entire planet swallowed in dust for months. Imagine you're a colonist living on the surface, and the sun simply goes out. Your solar power collapses. Your greenhouses dim. The temperature swings become harder to manage. Communications grow noisy. Outside, an electrostatic tempest of toxic, abrasive grains is grinding itself into every seal, every joint, every filter on every machine you depend on. You don't get to wait it out somewhere comfortable. You get to wait it out underground, in a buried shelter, sometimes for weeks, sometimes for months, hoping nothing critical fails. And here's the part that truly haunts the engineering of any future Mars colony. Repair from Earth is not coming. Mars is, on average, about 225 million kilometers away, but the distance varies wildly with orbits. At their closest, the two planets are around 54 million kilometers apart. At their farthest, more than 400 million kilometers. A radio signal, traveling at the speed of light, takes anywhere from 3 to 22 minutes to make a one-way trip. A real-time conversation is impossible. A medical emergency on Mars cannot be solved by a doctor on Earth. A failing oxygen system cannot be diagnosed in the moment. Every problem must be solved in isolation by people who cannot leave, with supplies that take 6 to 9 months to arrive, assuming the launch window even cooperates. Earth and Mars only align favorably for transit roughly every 26 months. Miss the window, and your resupply mission has to wait over 2 years. Now combine all of this. The radiation soaking through your habitat walls. The bones quietly thinning inside your colonists. The poisonous dust pressing against every airlock. The cold that never relents. The atmosphere that cannot be breathed. The storms that black out the sun for months. The distance that turns every accident into a potential extinction event. This isn't a frontier. It's a death trap with a view. And yet there's something even more unsettling beneath all of this. Mars wasn't always this way. Roughly 3 to 4 billion years ago, Mars had a magnetic field, a thicker atmosphere, lakes, rivers, possibly even oceans. We've found dry riverbeds, ancient deltas, and clay minerals that only form in the long-term presence of liquid water. Mars was, in some sense, a sibling to Earth. And then it died. Its core cooled, its dynamo collapsed, its atmosphere drained away into space, and its surface froze into the rust-colored ruin we see today. Mars is not a frontier waiting for us. It is a graveyard, a planet that already tried to be alive and failed. Some argue that this is exactly why we should go. To learn, to test ourselves, to become a multi-planet species. And as a destination for science, Mars is genuinely irreplaceable. Robotic missions there have transformed our understanding of planetary evolution, climate change, and the conditions under which life might emerge or vanish. The Perseverance rover is currently caching samples that may, one day, finally answer whether Mars ever hosted microbial life. That is a question worth answering. But asking whether humans should visit Mars and asking whether humans should live on Mars are not the same question. Living somewhere is different from surviving somewhere. Living means children. It means birth, growth, old age, recovery from illness, the slow accumulation of generations. It means a body and a mind that can flourish without constant medical intervention. Mars offers none of that. Every breath would be filtered. Every meal would be engineered. Every wall would be a barrier between a fragile interior and an environment that wants nothing more than to take it apart. The first generation born on Mars would grow up in gravity that may never let their bones reach full strength. Their hearts would develop differently. Their immune systems, isolated from the microbial diversity of Earth, may never learn the lessons our bodies took millions of years to absorb. They would not be Martians. They would be patients. And here is the sobering reality. We already have a planet perfectly tuned for human survival. Earth's atmosphere is exactly the right thickness to scatter cosmic rays and let sunlight through. Its magnetic field deflects the worst of the solar wind. Its gravity is the only gravity our biology has ever known. Its temperature range is the only one we are designed to live within. Even our worst environments, the deepest oceans, the driest deserts, the highest mountains, the coldest tundras, are infinitely more hospitable than the warmest, calmest day on Mars. The Sahara has more breathable air than Mount Everest, and Mount Everest has more breathable air than the entire Martian surface combined. When you look up at the night sky and see Mars as a steady, reddish point of light, you are not looking at humanity's next home. You are looking at a warning. A planet that lost its magnetic field, lost its atmosphere, lost its water, and is still losing what little it has left, particle by particle, every day. Mars is what happens when a world stops protecting itself. It's a preview, not a promise. Mars isn't the last frontier. It's the last place we should ever call home. Not because it's impossible to go there, but because going there should never be confused with belonging there. The dream of Mars is, at its heart, a dream of escape. But the truth is, there is no escape. Earth is the only home our species has ever had, and likely the only home our biology will ever fully accept. The energy, the brilliance, the resources we would pour into making Mars barely livable could instead be poured into keeping Earth thriving. One of those projects has a chance. The other is a slow, expensive, beautifully filmed funeral. I hope this gave you a new perspective on the red planet we thought we knew. Mars is one of the most fascinating worlds in our solar system, and it deserves every robotic mission we can send. But our home is here, beneath a blue sky, on a world that still knows how to keep us alive. If you enjoyed this video, consider subscribing, and I'll see you next time.